Welcome to the Ecomodernist channel live. I'm Carl Pauls. I'm here with Gabe Ignetti and our special guest, Dr. Chao. Dr. Chao is the author of a book entitled A Complete Perspective of Nuclear Energy. He's been a chair professor at the Tsinghua University of Beijing and a visiting professor at the Tokyo Institute of Technology. He holds a master's degree in nuclear physics and a Ph.D. from MIT in nuclear engineering. In California, he is a registered professional engineer in mechanical engineering. He managed and worked on nuclear safety issues for 23 years. For 17 years, as an editor for the Elsevier Journal of Nuclear Engineering and Design, he reviewed more than 3,000 manuscripts, which were submitted for publication, covering a complete spectrum of nuclear engineering subjects and topics. This is just a short list of his many accomplishments. Welcome to the program, Dr. Chao.
Thank you. So glad to be here, and I'm honored to be invited. So looking forward to have some nice discussion with all of you.
So right off with the questions, you've written a book, A Complete Perspective of Nuclear Energy, which is a literal encyclopedia of atomic energy. It states that all the topics of nuclear power are included: nuclear safety, waste, weapons, power plants, accidents, rockets, nuclear fusion, medicine, vaccines, proliferation, and light visions of nuclear physics and nuclear fuels. So what do you think is perhaps the best reason to own this book?
Oh, good. That's a very good question. Now, the notion is really, I believe the most people still really do not like nuclear energy. They don't say it openly. Now the trend is let's have a nuclear power, and I can accept that. I understand that. So why people feel that way? Very simple, and it's very natural. They fear radiation. If you guys build a nuclear power plant, fine. Don't build near my home. And I trust you guys doing a good job. But you guys be careful. So that's their attitude. Okay. And I didn't know that. I have been in nuclear engineering field for more than 45 years. And I didn't know that until 20 years ago, naively. And I look around. Wow, why when I engage a deeper conversation with a person I know, they really did not like nuclear power. So I thought, well, hey guys, you really should not have that attitude for not liking nuclear energy. But how can I blame them? Those guys say, okay, Jason, I believe everything you say, but I do not understand nuclear power. Well, the information is everywhere, but where? Good question. You know, it's the journal, it's a newspaper, it's in the books. Well, there's no such thing. Then once in a while, a reporter report an article in newspaper, something happened, you know, in Russia, China, in the US, nuclear power plant, small modular reactors. They print an article like that. Well, people say, okay, but that far less than what's needed. How many nuclear engineers are in the United States? 9,000. Among 9,000 people, I know personally 500 of them. And the nuclear engineers among them, they are divided, they're subdivided. There are 20 fields. One specialized in this specific field. They're very well known. They published 50 papers. They're professors, but they may not know the other nuclear engineering subject. Okay. So even professionals are subdivided. Now, among these professors, these professionals, they're good at what they do. Do they care about the public opinion or the state of the knowledge those public has owned on nuclear power? I have no time. I mean, I'm so busy. So this problem has lasted for 20 years, 30 years, 40 years. So people will never get to know nuclear energy until someone put this book together. This book has to cover all spectrum of the nuclear engineering subject and to put them consistently. That's the idea for a so-called small miniature encyclopedia. So I said, somebody got to do the job. That's number one. Number two, I was the editor for this nuclear engineering and design for 17 years. This long time is unprecedented. Unprecedented. Now, so I got a chance to review so many manuscripts. I had to understand them. 17 years. And that journal has a history of at least 50 years. So it's a reputable journal. So that's the golden opportunity for me to be in the position today. So I said, the public must have a source of information like this. And I cannot in the book say, guys, trust nuclear energy. Nuclear engineering is good. Our nuclear energy is good. This book says so. I cannot do that either because those guys, they're smart. If you try oversell them something, they're not going to buy it. So I said, look, I will start clean. This is information. After you read it or you get information, you still do not like nuclear energy. So be it. I'm good with that. That's, to answer your question, how I started writing this book.
Amazing. That's really cool because I've done similar work in state party politics in order to try to get our Washington policy changed. I'm facing a great deal of uninformed opinions, unfortunately, and whatever resources we can get in order to help persuade people to support nuclear energy, I greatly appreciate it. Some of these reasons that those people give us why they hate nuclear energy, of course, is, oh, Chernobyl, Fukushima. And so you've studied these disasters yourself. You're telling us backstage about how much your own report overlapped with the material of the HBO Chernobyl series. But we haven't yet seen a series about the Fukushima Daiichi disaster. Why don't you paint us a picture? What is it about the Fukushima Daiichi disaster that would end up in an HBO show?
Fukushima, it all started, say, in 1987. I worked for a group, a company in Palo Alto, California, called the Nuclear Safety Analysis Center, NSAC. Director was David Rossen. David Rossen later became Assistant Secretary of Department of Energy and now President of American Nuclear Society. He was my boss. I joined the group in 1981. I was a very junior project manager, if you will. I learned everything from all the experts around me. But anyway, to make a long story short, at that time, the Chernobyl happened. And I had a chance to participate in analyzing the Chernobyl accident. That subject I can talk about not 2 hours, but 2 days, every minute of it. But I will skip that. From analyzing Chernobyl, we learned what could be the disastrous situation for nuclear power plant at that time. We identified one. It's called tsunami-induced station blackout. If we had that, the nuclear power plant would be doomed. That's what 1987. Some utilities in Japan did not take it very seriously. Tokyo Electric Power did not take it very seriously. There's another example for me to say that. There's a new technology for called the PRA, probabilistic risk assessment. It tells your nuclear power plant is safe or not. If not, what do you do about it? If you put the equipment in, the safety level is going to be increased from 1.5 to 20.63. Okay, that's science. US invented that science. US Nuclear Regulatory Commission adopted science and make that a licensing basis 25 years ago, which is a great thing that happened. Tokyo Electric Power Company did not believe that. So when tsunami hit Fukushima, it was a standard station blackout. You wipe out the diesel generator, which is the station blackout lifesaver. Then the next level is the battery. Then the battery was exhausted, and everything that we predicted going to happen happened. But the Tohoku Electric Power Company that had another nuclear power plant very similar to Fukushima, and they believed it. Tohoku Electric Power Company in Japan owns the nuclear power plant called the Onagawa. They have greatest safety culture. So they said, the Japanese government did not ask me to do all this, but I must do that. If tsunami come, they could be safe. Same tsunami, there one day came, hit both nuclear power plants, wipe out Fukushima. You can see the mini-series lately, about just a few months ago, that how the accident was progression. But the Onagawa nuclear power plant was completely safe. There's two different outcome. So what happened? Well, one company believed in safety culture, believed that what we told them, the other one did not. That's the drastic different outcome. That is my answer to your question.
I don't know if you know this individual. He is a retired Captain Reed Tanaka, who was a part of the Navy briefing team when he was sent around to brief all of the service families. And he gave us an excellent briefing on the Fukushima Daiichi disasters. And so from that, and from my independent study, I know that not all of the TEPCO reactors failed. In fact, there is a significant amount of heroics done by people on the ground there. And in fact, there was Fukushima Daiichi and Daini. And collectively, they have 10 reactors. And at least, I think, 2 to 4 of them were saved by the workers. The rest maybe not vulnerable, but a couple of them, they brought out these enormous power cables at Fukushima Daini, and they saved one of the reactors that way using these enormous cables. And as well, the plant operators, disobeyed their bosses and started flooding the turbine building with seawater. This would ruin the reactor, but the reactor was melting down. So this is the lesser of two evils, obviously.
Yeah, yes.
There's all sorts of wonderful stories in Fukushima Daiichi and of course Onagawa, the safety of the townspeople there being sheltered in the cafeteria of Onagawa, another great scene.
Okay, I had a solid experience analyzing nuclear severe accidents. Let me give you one specific example. Most people, if you don't make hot tea, but when you do, you turn on the gas stove, you get hot water. That tool, kettle, how many times you use it? 100 times? How many years do you use it? 10 years. Why is it not broken? You gotta catch fire underneath it. It still be good. Why? Because outside there's a fire, inside there's water. So when the water inside and the fire outside, that kettle will be good. And for 10 years, 20 years. Same thing with Fukushima. So during station blackout, there's no water to save plant. The scenario, the nuclear accident scenario, the worst is not a hydrogen bomb explosion. Hydrogen explosion, no big deal. What's the big deal? Big deal is the reactor pressure vessel melt through. So after the core is melted, it melts through the vessel underneath it and come out. That's the worst scenario. So, but anyway, now going back to the boiling scenario on your stove. If the vessel is held in there, if you flood the containment to let the vessel soak in the water, doesn't have to be halfway, 1/3 away from the bottom. Your vessel will be saved, just like you boil the water on stove. The water will keep the vessel intact. And then the power plant will be saved. And then the vessel is saved. Inside the vessel is a molten core. It's messy, but you could take it out. It takes 10 years to take it out. And you can still refill it. I can still use it. But their problem is they did not believe all the procedures. Everything's written in the procedure, and they don't have any. But in the United States, everywhere is procedure. No one dares to deviate from the procedure. So that's the story, one aspect of Fukushima. I just got to tell you for several things. Number one, I should really say that the Fukushima, those guys, they're ignorant or they did not care for safety culture. No, that's criticism. This is not the time to criticize them. But I will say they definitely missed something important, and that caused the accident. And the other nuclear power plant did not. They are safe. Two, United States, that will never happen because the regulation, the procedure is rigorously followed. And I have a great confidence. Now I can say that progression. But the Onagawa nuclear power plant was completely safe. There's two different outcomes. So one company believed in safety culture, believed what we told them. The other one did not. That is my answer to your question.
The public has a big problem with nuclear still, and even our NRC, Greg Yatsko, and all these people had a problem with nuclear following the Fukushima Daiichi disaster. And they requested a safety review. And I believe this is called the Beyond Design Basis or the Flex Response Program. Do you know anything about this? What could you tell us about that, the US response following Fukushima Daiichi?
Okay, I can tell you a lot about it. In the US, to put it bluntly, US regulatory knew the scenario, knew the severity of this scenario. So I don't think they did not know what happened. The process to find out what happened is worth the effort. But once they knew what's causing it, in the US, there's no such chance that this could happen in the United States. So you have to review it because that's nuclear NRC's job. So my position is that the US regulatory has done more than enough, has done most adequate job. Wow, hey, you are me. You are pro-nuclear, so you are on their side. No. Give you another story. Let's go back to Chernobyl. When Chernobyl happened, I led a team to analyze the entire Chernobyl accident. Okay, that I'm talking about nuclear reactor physics. Okay, now when it happened, Chernobyl had a two explosion, bang, bang. From reactor physics standpoint, there I need to tell, from our own benefit, was that a nuclear explosion? Was that a steam explosion, or that was a hydrogen explosion? See, Fukushima is a steam explosion. Okay. Now, what happened in Chernobyl was that they violated procedure. It was a Communist Party Commissar. Commissar is a Communist Party political officer who watched over the entire operation. But anyway, it's for the personal gain. And the movie talk about it. Today, I'll not go into that. But the subject now is the NRC. NRC at that time say, guys, something happened over there. NRC, I have the power to shut you all down because I am the watchdog for the nuclear safety for the United States. You shall prove to me your nuclear power plant, and there were so many of them, that your nuclear power plant will not have any scenario like Chernobyl. Prove to me first. because I have the power to shut you down now. Okay, but US utilities, that's a good point. Frankly, this is our preliminary analysis. It does not really show that anything happened in Chernobyl can happen in the United States at all from the fundamental nuclear reactor design standpoint. So NRC said, that's a good point. But watch out, guys. So NRC is doing a great job at that time. We have no responsibility to answer the question, but we support all the nuclear utilities in the United States. Say, let's do the analysis to demonstrate that everything happened in the Chernobyl will never happen in the United States. So at that time, the nuclear utilities in the United States facing the threat of being shut down across nationwide. So I have to give NRC great credit for that. Look, Japan. Japan has a similar organization, and they told you, the Japanese nuclear utilities, you prove to me that everything happened to Fukushima will not happen to your nuclear utility. Or I will shut you down. And guess what? They all shut down. Okay, so what I'm telling you is that NRC has done a great, great job in the United States. And there was such a history, and public will not know about it. And so we did some hard work to work towards the protection of a nuclear power plant to keep that nuclear power plant safe. There is a great effort behind it. That's the point I'm making now.
Great, thank you. You've told us about the response to Fukushima and Chernobyl. Could you generalize for us a bit now? You have so much experience. What is your assessment of nuclear safety worldwide?
Okay, before I touch the subject, which is a great subject, I would say globally, Western world, their nuclear power plants are safe because they follow the rigorous procedure during the nuclear power plant operation. Nuclear power plant everywhere, their hardwares are made robust enough to call it safe. However, the nuclear power plant are being operated following the operating procedure. And that procedure can never be deviated for safety measure. So everybody knew that. That is rigorously followed by the Western world. Now I will give you another concept. It's called the quality assurance, QA. Let me give you another concept. It's called Wall Street stock and security. The underlying thing is you trust everything that's been published about the company, the book, the earnings, the personnel, so you make a judgment on the stock. There is an audit system to go in to audit those books, and those audit process needs to be performed through a third party. They all rely on the third party audit. Okay. So is nuclear safety. But there is a different world outside the Western world. Sorry, there's no such thing as called a third party. There's no such thing called a second party. Okay, there's one party. So am I being political? I don't want to be, but I can help. And those guys, they also have operating procedures. So 2 years ago in summertime, just about when I gave a public speech on nuclear safety, and I said that those who did not follow the operating procedure were in big trouble. And I openly predicted where and why the next nuclear major accident is going to be. So 3 months after I said that openly, something happened in the nuclear power plant in China. What happened was that the nuclear fuel rod failed. Big deal. How do you know it failed? Well, how come at a certain area the radiation level went up? Nuclear rod failed will cause that. Professionals know that. So what do? Shut it down, replace fuel rod. Okay, that'll be okay. That's a procedure, and procedure says so. Do that. They did not do that because the nuclear power plant was being operated during the summer hot weather. The entire country has electricity shortage. There you don't shut the nuclear power plant down. Who has the power to say that? Those guys now who want to please their boss. Okay. So the procedure said if the radiation level at this place says this, you shut it down. The guy came out with the position, we made a procedures years ago. It's too conservative. We can still let it go up. That's a big no-no. Violating the safety procedure. And to me, you are walking towards death, forwarding, no chance to save you anymore. Fortunately, two things happened. The partial ownership of the Chinese nuclear power plant was Framatome, a French nuclear vendor company, said, this is no good. But I'm just an owner. I have no opening. Guess what? They called up a new US NRC. So look, this guy did a bad thing. The US NRC said, hey, it's over happened in China. It's not my jurisdiction. So that happened once. The second thing happened and saved it. The radiation still went up, still went up, still went up, still went up. So the basis the Chinese brought out saying, we were too conservative in the first place, so we can still live with that. That did not go well because they keep going up. Okay, we better shut down. So they shut down. That's where I said, if you don't have a safety shot and safety culture, if you don't let the last safeguard to guard you, you will not be safe. This is where I predict the next nuclear major accident going to be and why.
And so this was a big international incident. If I am going to compare this to other US systems, like in my own state, in Washington, Columbia Generating Station, sometimes Columbia will be under no-touch orders. And that is because we have very, very high power demands. And what you're telling me, Dr. Chao, is that a no-touch order at this plant caused an override of safety protocol. And in the West, that would not be allowed to happen.
Correct. No, it won't happen in the United States. Somebody will go to jail. Number two, the Nuclear Regulatory Commission is an independent organization. Their budget does not come out from administration. The US NRC, the commissioners report to the President of the United States. So it's entire independent organization. Just give you another story. Okay? 1973, there was no NRC. There was no Department of Energy. There was a huge organization called the Atomic Energy Commission. They have two jobs. It's conflicting. So the US government said, this conflict of interest, no good. We need to split them up. The Nuclear Regulatory Commission is an independent organization. They just go in and check you out and order you follow the procedure. There's no way out. There's no second chance you could do anything differently.
If I can, I want to draw a comparison. France has problems sometimes, and I think they're a safe fleet in general from my impressions. But there's the public fear that France's reactors are in danger because of their cooling water. And so if the rivers are too hot, they're forced to shut down. And what does the public know? Why do they shut down? They think it's safety. And so What I discovered is that this is an ecological restriction, in that this is operational orders. You may not put too much heat into that river. When the water is too hot, you must reduce your outlet temperature. You can't
Yes.
put too much heat into the river because of the local ecology.
Yes.
Now, there is a difference. There is a no touch because of human suffering, because we have too much energy demand, and there are some plants that are allowed to bypass this ecology in order to save human suffering from happening. Do you have any suspicions that France would be allowed to bypass their safety regulations for a similar no-touch order?
Absolutely not. French are conscious scientists, and I went to France a lot, and they are ahead of the game, by the way. They are ahead of United States. The number one nuclear developing country is France. If you talk about the nuclear waste management, the nuclear fuel cycle, I can bring them in and we'll talk about it, but it's going to be another 3 hours. So I will just go away from the subject. To answer your question directly, I don't think French will ever do that. I don't think they ever done it. They knew better. They don't have to. They don't have to. They have enough safety margin. Okay. Now say that okay, we shall not put water released from nuclear power plant too hot. Well, so those guys are great guys, right? You see, when nuclear power plant is built, they have a two-step process. The first step is called the preliminary safety analysis report. The government, the regulator said, tell me, describe what it is. So the first step is a description. Then, years after that, they approved it. They issue a report, final safety analysis report. What is report? Big deal. No. The final safety analysis report is the contract between the regulator and the power plant owner. What does that mean legally? It legally means you, the nuclear power plant owner, has given away certain rights, voluntarily to the authority. The contract said you shall not release water hotter than certain temperature. If they violate, the regulator will step in and say, I'm going to shut you down. And you're going to owner take this financial loss big time.
Okay, yeah, I had a question about concerning the water. I read that your company has a technology now for any kind of a steam plant, nuclear, gas, coal, whatever. They have a technology that will turn the hot water into electricity at a very good rate, so that it kind of solves that problem. Have you heard anything about that?
No, I've never heard that thing. And I need to know the specifics, number one. Number two, during my career, I live in Silicon Valley. There's a lot of investors. They came to me and said, Jason, I have the investor telling me they can do this, they can that. This is a report. Could you tell me it's good or no good? I did a lot of them. Most of them are no good. I just do not have enough
information.
Yeah. In the thermodynamics on the second law, you never be able, based on the physics we understand on Earth, that used up the heat, converted into energy 100%, 40% max. Now, what about the others? The rest of the energy, you dump them. So that's engineering-wise, it's inevitable.
You were talking about our kettle and our kettle on the stove lasting 10, 20 years. What is the age at which a nuclear plant must be shut down because its kettle is wearing out or any other part of it is wearing out?
Good point. Good point. Let's talk about some physics. The vessel, I think now even either 50%, 60%, 70% of a nuclear power plant in the United States being granted the permit to call a life extension. Instead of the original license allowing them to operate for 40 years, now they allow them to operate up to 60 years. That's a long time, okay? Well, I won't guarantee it, but I believe in the process. The US NRC say, okay, 60 years okay, but they never say that. They say 60 years is likely to be okay, but you need to let me check your vessel ingredient every year, every 2 years. Okay, then it's okay, then I let you operate. If not, shut it down or decommission. Okay, that's the process. Now, the gas stove had a way of degrading the kettle. In nuclear power plant, the reactor vessel, that the degrading process is called the neutron fluence. Neutron penetrate those 6-inch thick metal, basically is steel. And those material will be degraded, for sure. I will not say it can be operated. I have not seen the data. The likelihood could be extended to 80 years. But let's see. If for the time comes, if they ask for this extension, and let's do the examination, let's do the licensing process. If they cannot pass, so be it. To answer your question, now we're talking about 60 years for sure, but 80 years a possibility. And I do not know much about what's beyond 60 years enough to tell you one way or the other, but it's a possibility. We shall see. If not safe, shut it down. Because 40 years experience already, you already get your money back.
Yeah. Is annealing of the reactor vessel promising, or is that not interesting to you?
No, it's very interesting. It's a process to heal the damage. There could be the point that that process will not help much or not worth the investment to go in the trouble to save the vessel.
You say annealing? Excuse me, doctor. You say annealing? What?
Annealing is a process that is a piece of metal. You heat it up. This is the physics. This 6-inch vessel is a very thick metal wall. Neutron bombarded every day when you're in operation for 40 years, and it makes holes in the metal inside, and those holes will degrade the vessel so that ductility will be reduced. Annealing is you heat it up to a very high temperature, and those air bubble, those empty spaces created by neutron inside the metal will be gone. That's the process called annealing. And I trust the process. I just don't know what economically viable in 20 years from now or not. So I'm just speaking scientifically, but when the time comes, if I am hired as a judge, I would say, show me the data.
So what can you tell us about the cutting edge of molten salt reactors and other fourth generation designs? I know that there is a 100 megawatt in China is the pilot project that's been started up, and there's several United States advanced designs under the Advanced Reactor Demonstration Program. What is your view over these advancements?
Very positive, but I could address different aspects: technology, economy, and what's going to happen in 10, 20 years. Okay, the technology is amazing. Molten salt, so a lot of excellent scenario that we have seen today will not happen. There's no hydrogen producer anymore. It produces hydrogen, causing the Fukushima hydrogen explosion. That won't happen. So molten salt is great. Molten salt is great in the sense that the fuel and the coolant are one big liquid entity. It's flowing out all together. So what? Well, during the operation, you can reprocess, taking the waste out, inject a new fuel, so the operation can be kept continuously. And that's good because you're saving the operation time, but you, of course, can never operate it forever. You need to shut down to do the maintenance necessary. There's a lot of advantages. But the process will call for rigorous testing. let's test it. NRC said, okay, show me the design. Show me your testing data. And that's where everything got hung up. Doing the testing, we should do the testing, showing the data. How long would that take? 5 years? 10 years? Okay, so that process cannot be skipped. Technology-wise, great. Our process is there. There are several places we could use it. Small modular reactor. Well, I would say I think not, because of public acceptance. Well, hey, nuclear power plant is great. Small modular reactor is great, but don't put it in Stanford shopping mall. Okay, it's going to ruin your real estate property. It's going to ruin your real estate value. That I can understand. So how long would it take the public to accept that? I don't know, 5 years, 10 years. But before the small modular reactor will come out, there's another type of reactor called a micro reactor. It's smaller than that. Well, there is a market. Why? There's remote places. They need much smaller nuclear power reactor to go there to produce electricity. There's a lot of territories. There's a no man land. If you kind of develop the place, you need a power. Well, who's going to pay the money to build a power plant to develop the area? Okay, well, a micro nuclear reactor can do that job. There's no people, there's no real estate issues there, and that is going to be used wisely, quickly. 10 years after they use it, oh, it's good, it's safe, and we know how to operate, and this is the best way to do it. Then the small modular reactor will come in. Another market is all the ships. There are 60,000 ships globally that's running every day. They're producing carbon. And they are talking about converting those ships to be nuclear powered in 20 years. But I should answer your question straightforwardly. The technology is great. We are doing the necessary step, testing it. And the market, we need to move in with some consideration, put it this way. That will be my answer.
And of course, the NRC is demanding much testing data. And so we had a partnership between TerraPower and at first Russia and then China. And both of those relationships have unwound. And so, of course, they need their test data. And so now the ARDP is going to be providing that data. Very fortunate to have some great conversations around that recently. So maybe we can bring you back to have an interview where you can speak about things that my friends won't speak about publicly.
Okay, all right.
Wonderful, thank you. Given the advances in extracting uranium from seawater, do you think just that uranium seawater will be able to eliminate mining? And at what point in the future do you see mining uranium out of the ground being unnecessary?
This subject is very interesting. Let me start with some facts. The seawater technology has been proven okay, but mass production still take time. But why people are interested? Because the uranium in the seawater, the reserves is about 100 times than the uranium mine. So it's a great resource, so why not? How far in the future we could use the uranium from seawater, I don't think it's the question on technology. I think that now Japanese are testing it. MIT, also has some invention on the materials. The new materials that can effectively extract the uranium from seawater, and those are great. But who should put out the money to develop technology to mass produce it? I don't know, unless that question is answered, and the physical digging of the uranium mine because of health issues. But see, in 20 years, that may not be an issue. Why you send a human being down there to dig the mine? Let's use robots. Now, today's robot is doing great. How about 20 years from now? Okay. So that issue may not be an issue. Therefore, getting uranium from seawater or from mine, there's a lot of unknown.
We have this fund for nuclear plants that accrues at a fixed rate per kilowatt hour in order to make sure that there are enough funds to decommission the reactor, so that no matter what happens, when this nuclear plant is done, it can return to green field. This is the only industry which does this. This is the only industry which takes care of its waste, which takes care of all of its infrastructure for fossil fuels, for industry, for chemical wastes. They have Superfund sites and they have brownfield sites. Nuclear industry, it's all greenfield. And in fact, there is so much money in these funds that it is a very attractive investment to buy a nuclear plant and shut it down. If we could limit that incentive to shut down nuclear plants which have a mature decommissioning fund, I assume you would support it. And what could we do with those funds under the NRC? If the NRC was in charge, or perhaps the DOE as well, if the NRC and the DOE each had a share of those funds to put into backstopping against accident funding, to fund research, to fund anything else in the nuclear energy industry, where would you put that money?
The safety issues are properly addressed. The operating issues, no. Training, we're doing a good job. Where are the new subject is worth the money to put in? Okay, I will say nuclear fuel cycle. For example, we're producing a lot of used once nuclear fuel. Okay, that is a totally different concept. The nuclear power plant taking out used nuclear fuel rods, put on the site. Those should be reused. Why? You should be, because if you don't do something about it, you could, from today's economy, you can say it does not pay to reprocess it, to take it, useful ingredient out and reuse it. Why don't we just take out more uranium and use it as a fresh fuel? Keep on doing it, and guess what? At the back end, you accumulate more and more, unused rod. Well, okay, we're going to put it underground. So many of them enough to take care of all of that. That's number one. Number two, what if the plutonium produced in the fuel, one of these, somebody take it out to make a nuclear weapon? So there's so many unaddressed issues unless you can properly address the nuclear fuel recycle issue. By doing what? Well, you should develop the next generation of nuclear power plant. Today, nuclear power plants are based on so-called slow neutron. And they came up with a lot of unused nuclear fuel. Use them. Develop the next generation of nuclear power plant is called the fast neutron technology. The fast neutron technology can burn nuclear fuel as well as burn the waste while it's producing. That's amazing. Only nuclear can do that. Sorry, I take that back. You burn a gas fire on stove, you can do that too. But that's an important step to do something with the new technology so that we are really solving today's problems. Okay, so that's, as I see, is where the money will be worth its while to put in to enhance the nuclear fuel cycle technology. I just want to use the opportunity to tell people that nuclear energy is nothing to be afraid of. We should never fear radiation. The nature of the universe is nuclear. solar power and the wind power are nuclear. If there's no sun, there's no sunlight, you will have no solar energy, no wind power. So don't be afraid of radiation. Heck, come on, radiation gets you cancer. Not necessarily. There's a new subject called the 1 million person study. Go Google this word. 7 or 8 years ago, United States came out with a new subject. They performed a study to find out if low dose radiation could do the health benefit. They could. The data says so. How? We don't know for sure. How much? We don't know for sure. Find out. The 1 million person study, where the 1 million people come from, is come from the employee of Department of Energy, a national laboratory. NIH sponsored the radiation environment laboratories. The military personnel, 30, 40, 50 years ago, they watched, the atomic explosion, the test. They all experience radiation. They don't die. A lot of them, live very well. Why? Honestly, we don't know for sure yet. People have some guess, and there's certain mechanism. But they certainly, a lot of them live very well. I mean, and so the article, basically, published article says, if you experience radiation level low enough to be in the health benefit range, you will live 20% longer. That's the statement. So I made a joke out of that. By the way, everybody had COVID vaccine 2 times. And when you're a little boy, you had a vaccine. Now I have taken every year the flu shot vaccine. Imagine 20 years, everybody line up to take extra rates. That's the new vaccine coming out. Why? To boost up your energy immune system. Well, how do you know that? I don't. But the data says there's such a thing there. The American Nuclear Society about 3 years ago had an article in their monthly magazine, says it all. Okay, we are not trying to push something we do not know. There's no salesmanship here. The point I'm making here today is, yes, you should be afraid of radiation. Don't let too much get to you, but don't be afraid of it. Radiation can do a lot of benefit to human culture, technology, life. If you're afraid of radiation, do something about it so it won't get you, but use your wisdom to take advantage of radiation. You are afraid of radiation is psychology. It's a different question. Technology-wise, it's not a question. I guess I will just say that for today.
Wonderful. Thank you so much, Dr. Jason Chao. It's been a pleasure to have you on the program. And thank you, everyone.
It's my pleasure. It's a very honor to have the opportunity to talk to you guys like this. And I enjoyed it.
Thank you.
Great.
Okay.
Please subscribe to us on YouTube, Ecomodernist channel. Also to subscribe to us on Twitter and Facebook, Ecomodernist Society of North America.
And online at https://esna.earth.